For most of you, reading the slide behind me is completely effortless. But for some people, this is a task that gets harder and harder every year as their vision deteriorates. While many of us take it for granted, vision is an absolutely essential sense that allows us to navigate the world around us, create and consume art, and so much more. When light enters the eye and hits your retina, it's processed by layers of specialized neurons that convert the light into patterns of electrical activity. These patterns of electrical activity form a language that the brain uses to communicate. My research studies the rules of this language. Some languages, like English, combine letters to form words. We call this composition because we're building bigger concepts out of small building blocks. Conversely, some languages use unique symbols for every word, like Egyptian hieroglyphs. In the brain, an English-like letter-based system might use 3 different patterns for red, green, and blue, which you can combine to form every color. This might look like representing purple as halfway between the pattern for red and the pattern for blue. A symbolic hieroglyph-like system would require a different pattern for every color, and you wouldn't be able to generalize to new colors. Understanding this language is important for things like developing better visual prosthetics, where the idea is to turn images from cameras into patterns of electrical activity that the brain can understand. This is a really difficult problem because we don't have a Rosetta Stone for the brain. My research tackles this in 2 ways. In the first, we use computers and machine learning to identify these complex patterns and classify them as more English-like and compositional, or more symbolic, like hieroglyphs. In the second part, we train many small artificial neural networks, a form of AI, under different conditions to identify what factors influence the type of language that the brain uses. This will help us predict whether different parts of the brain use different languages or dialects. Our work is ongoing, but our early results indicate that are consistent with a more English-like, letter-based compositional system for visual language. Our hope is that one day we will have visual prosthetics so good that no one has to worry about reading a slide ever again. Thank you.